Okay, shh. Good morning, everyone. Today we will be looking at some diagrams so that we will be able to understand the rules in adding and subtracting fractions. We've got 3/5. We want to add it to 1/5. Well, that's your 3/5 there, and this is your 1/5. And it makes sense that we're just really adding 3 and 1 to make it 4/5, because now our fraction here becomes 1, 2, 3, 4 parts out of the 5 equal parts. Okay, now I hope that you heard that term, equal parts, and that's what we've always emphasized when we started talking about fractions. The whole needs to be divided into equal parts. Okay, and so we've always heard, our teachers saying that to add fractions that have the same denominators, we simply add the numerators together, and then the denominators remain the same. And why does that work? Because looking at, again, from this diagram, we've got 3 parts, so 3/5. We add a 5th, and therefore we now have 4/5. Okay, so 3/5 means 3 lots of a 5th. When we add another 5th, then there's 4 lots of 5th, which makes it 4/5. It makes sense, right? Now, with that in mind, you can actually do any of the questions here on this slide. You can choose 2 from each column. If we were to do maybe the 4th one here, we simply add 3 and 6, we get 9/8, and we say 9/8. Now you can simply further simplify that and write it as a mixed numeral. We know that 9/8 would look like it's 1 whole plus 1/8, so that you can even say that's 1 and 1/8. The same thing when we probably want to do this one here, number 7. We just say 7/10 plus 1/10, that's 8/10. And we know how to simplify fractions. We simplify it to get what? 4/5. So pick any 2 from here, pick any 2 from this column, pick any 2 from here, and then write it down in your books, etc., etc. Maybe your next question is, what happens when the fractions do not have the same denominator? And I guess when we started talking about fractions, the first thing we learnt about is figuring out equivalent fractions, right? So looking at these drawings here, we can say that a half can look like this one here. A half could also look like 3/6, right? And they are what we call our equivalent fractions. A half and 3/6 are equal in value, but they have different denominators, different numerators. Okay, and that's what we've established before. Equivalent fractions are those fractions that have equal value, right? But look different. Okay, the same thing with maybe this one here. We know that this is a third, and this one is taking 2 parts out of 6 parts, 6 equal parts. And we know that these 2 are equivalent fractions. Okay, now maybe you're wondering why we started with that one. Why do we want to rename fractions? Well, it's because not all questions that involve adding or subtracting fractions would be somewhat kind or friendly, right? Sometimes they would look like these ones here. And the first fraction here is a half. And what we want to add it with is a third. Now, these 2, we can't just say it's, we just add the numerators and ignore your denominators, because they don't have the same denominators here. So what can we do? We want to make sure that these fractions or the parts would be of equal sizes. Looking at this part here, that doesn't look like it's the same as this one, precisely because this one whole thing is divided into 2 equal parts, whilst this whole here is divided into 3 equal parts. But what if I divide the first whole into this, and I copy the one on the other side? And the same thing with this one here, right? Let me just move that quite a bit so they look, I can. I can't. There. So then now we've got these 6 equal parts, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6 equal parts that this whole is divided into. And we can rewrite them so that, or we can rewrite the fractions so that a half, we can say it's equivalent to 1, 2, 3 parts out of the 6 parts. And then this one here, 1, 2, 2 parts out of the 6 parts. And that would be equal to 5/6. And indeed, if we do that, the same division to our whole here for our answer, then we could say, well, we've got 3 parts taken here. That's 1, 2, 3. And then we're adding 2 parts here. So then that's 1, 2. Therefore, you now have 5/6. And therefore, indeed, a half plus a third is equal to 5/6. The first figure there, the fraction we're after, is that it's 2/3, because it's 2 parts out of 3 equal parts, whilst this one here, it's 1, 2, 3, 3 parts out of 4 equal parts. Yeah, so we're adding 2/3 and 3/4. So what we want to do is come up with how we will be able to divide this one whole so that we've divided it into 3 and also divided it into 4 lines as what I have on the other. Then I would have that. And then imagine I did that properly. Let me just move them a bit. That looks nicer. Right, and then I do the same for the other one so that I divide that into 3 vertically. Right, so now I could rewrite 2/3. I can rename 2/3 so that now it would have 1, 2, 3, 4, 5, 6, 7, 8, 8 out of 12 parts. And then the other one is 9 out of 12 parts. Yeah. So now I've got 8 out of 12, 9/12, and just like what we said with adding fractions with the same denominator, we can simply add the numerators together. We can have 17 out of 12. And what does that look like? Well, 17 out of 12, that's really 12 out of 12. Why did I want 12 out of 12? Because I know that 12 out of 12 is also equal to one whole. It's 12 parts. You're taking 12 from that 12 equal parts. So it's one whole that you're actually taking. And then it's what left over 5 out of 12. Yeah, so then what that might look like is this. So then now I have 12 out of 12. I can just color in the whole thing, but I have 5 more. 1, 2, 3, 4, 5. You could probably say that if we're adding fractions with different denominators, what we need to do is to come up with a way so that we can rename each of the fractions wherein they would have the same denominators. okay? So that if we are to add fractions that have different denominators, we change the fractions so that they have the same denominators. Add the numerators, the denominators stay the same. Let's do this one here. 2/3 and 3/4, which is what we had a while ago with the drawing. Let's do it without the drawing. We think of a way so that we can rename 2/3 and 3/4 so that they have the same denominators. We've got what? So when we're thinking of that denominator, we want to look for its least common multiple, right? So the multiples of 3, the multiples of 4, you could even write them down. What are the multiples of 3? When you say multiples, it's keep counting by 3. So you go 3, 6, 9, 12, 15, etc., etc. It goes on forever. With a 4, you'll have 4, 8, 12, 16, etc. We just want to have the common one, which is the least one, right? And in this case, it's the first one that will appear as a common multiple. And in this case, it would be 12. So if we've got 12 here, 12 there, now we want to rename 2/3 so that it has a denominator of 12. What did we multiply to 3? To get 12, we multiplied it by 4. And for us to not change the value of your fraction, but change what it looks like, we're renaming it, then we want to multiply 4 on top as well, okay? Because then if we're multiplying 4 over 4, 4 over 4 is equal to 1. If you multiply 1 to any number, any fraction, any number at all, it stays the same, right? So 2/3 times 1 would still be 2/3. The value of that would still be 2/3, but now it's not looking like it's 2/3. What it looks like now, it's 2 times 4, which is 8, and therefore that's 8 out of 12. And we know that 2/3 is equivalent to 8 out of 12, or 8/12, okay? What did we multiply to 4 to get 12? We multiply it by 3, and the same thing when what we do with the top, because again, we're just multiplying 3 over 3, we're multiplying by 1. 3/4 times 1 is still 3/4. The value doesn't change, but what it looks like, it changes. So that we have 3 times 3, that's 9. And therefore we have 8 plus 9, you get 17 out of 12, or 17/12, right? And therefore that's 1 whole. What's the leftover? 5/12. Therefore we say it's 1 and 5/12. Now, some of you have already recognized that this one here is what we call an improper fraction. Right? Why is it an improper fraction? Because you've got your numerator bigger than your denominator, right? That value would be equivalent to this. This is what we call our mixed numeral. Why is it mixed numeral? Because it has a whole and also a fraction with it, okay? But their value would be the same. Do these questions here. Again, you can just select any 2 from each column. You don't have to do all of them, right? You might want to check with a partner or check with your calculator, or get a calculator and check your answer after you've done these questions here. Okay, now the title of our lesson today is adding and subtracting. We haven't done subtraction, but maybe from the addition of subtraction that I've modeled to you, maybe you can come up with your own rule. You can come up with a rule with your partner, right? You want to say, for example, 3/5 minus 5th. Why is that 2/5? If I were to say you've got this 3/5, that's 3 parts out of the 5 equal parts, and I want to get rid of 1/5, 1 of the fifths, right? Then what does it look like? Not shading. What does it look like? then now it's 2/5 left over, right? Which is indeed what we've got here. Okay, so I want you to tell me the rule. What could be the rule if what we have here for adding, subtracting is this one here? What would be the same? What would be different in your rule here, right? If you were to write the rule for not addition, but instead subtraction of fractions, okay? So you want to write that rule down, and maybe you can continue with looking at the rest of the slides for today and try these, right? Maybe with a partner or a group. What would be 4/5 minus 1/5? Once you've established the rule that you've written here, maybe look at what the rule is and then maybe apply that here and see if you get the same answer as your partner, or maybe using a calculator checking your answer, right? And then you might want to do these next, okay? Right, so good luck with your questions. I'll see you next lesson. Stay awesome. Bye.
Come on, Rocky, let's go.